Hello, everyone, and welcome back to your new channel. I changed the name to Basic Math and Engineering because I had another channel of basic engineering, but I found that it makes sense to combine them into just one channel since some people like to have some engineering and others they may prefer math, and yet others may have, a need for both. So, having said that, today I wanted to start talking about simulation and how are we going to do simulation with our studio and what's the reason behind it. Okay, so first of all, we need simulation. Sometimes because maybe the computations are very complicated and we can do it manually. Sometimes we need to gain insight about the theory itself that underlines a specific phenomenon. So before we start discussing that, I will go over one of the probably the basic simulation that many people start with, and the reason is they start with it to give you confidence that the answers you are getting from a simulation make sense. So we start with something we know beforehand. And one of the easiest things would be to estimate pi. And you say, pi? Why would I estimate pi? Again, the reason is I want to rely on the simulation to give me an estimate of pi. We'll see how we do that using geometry. And then if we see the answer, for example, turns out to be like 12.1, I say, no, simulation is not, that's a horrible thing to use because we know, pi is 3.14, and many of you know, up to 100 digits. I'll ask you on March 14th. Remind me then. Anyway, so if we get an answer like 3.11 or 3.16, and every time we repeat the simulation, we get another value. Of course, every time it's going to be slightly different, but they would be around 3.14. And you say, oh, yeah, now it makes sense. I can rely on that. Or I can, and maybe in the future I will show you that sometimes you use simulations to estimate tough integrals. What? How can I do that? Again, maybe I'll get you an example, an easy example for which we can integrate and find the area under the curve, and then we see how we can use simulation to estimate that and see if it makes sense or not. But today, as I said, we will start with estimating pi. So how are we going to estimate pi? Again, that's a very classic example. Oh my God, there is my... Okay, it's a very classic example where we are going to draw a circle, okay? And then we are going to say, let's place this circle inside a square, right? So maybe, of course, it's not going to be very accurate here, but just an idea, get you the idea of the simulation. Okay. So you see here that the side of the square, let's call it S, is the same the diameter, as the diameter of the circle, right? They are exactly the same width. So if I say area of rectangle, oops, area of square, yeah, a square is a rectangle, equals a square, right? And the area of the circle is pi over 4 s squared, right? Diameter is s, so you get, which means that the ratio, so area of circle divided by area of square equals pi over 4. Nice. So what I'm going to do is I'm going to generate random numbers from the uniform distribution. Let's say the origin here is 0, 0. And maybe I start negative 1/2 to positive 1/2, so the area would be 1. It doesn't matter. I can say negative 1 and 1 for x and negative 1 and 1 for y. So I'm going to generate two random numbers that will give me an x and a y coordinate of any point that I generate. So suppose the point is here, okay? So I'm going to measure the distance from the point to the origin and call that d. We know how to do that. The nice thing is that we pick the center to be the origin so that the distance here would be the square root of x squared plus y squared. I don't need to subtract anything, right? And then I'm going to say if the distance, that distance is less than the radius, and the radius here would be 1 because you see I made that a diameter of 2. So if the d is less than 1, give me 1. And if it's above 1, give me 0. So I will generate like 10,000 such points. Some of them will be inside, some of them will be outside. If I take the number and divide it by the number of points that I generated, which is 10,000, I expect that to be, and then multiplied by 4, I expect that to be pi or very close to pi. Okay, so that's a very simple case. So let's see how we can do that with RStudio. Here's RStudio. We always start by clearing the environment, which is already clear, but just as a habit. And then I'm going to create a matrix. And this matrix would be of size n, where n, we can pick n as we want. Like, let's say n equals, we said 10,000, right? It doesn't matter really, 10,000. And then I'm going to create a matrix. Let's call it pi, the pi matrix. Okay, pi matrix or pi m mat. And that equals, and the way we create a matrix um, in RStudio is so easy. You simply say matrix, and then you say, okay, how do you want to fill it up? You can say NA, meaning nothing, it's not available now, or you can make it zeros, a bunch of zeros, okay? And then it asks you how many rows and how many columns. How many rows? I want n. I'm not going to type 10,000 because maybe later I would say, okay, let me try to run it for 50,000 and see if there is a difference. So I'm going to say n. If the number of rows is 1, because you have only one column that you will store in it zeros and ones. So you don't need to say comma 1 because that's the default. The default is 1 and 1, which, you will not create a matrix to have only one entry, but they tell you maybe you have many columns and just one row, or maybe you have many rows and just one column. So that's why you can see here. And usually if you are going to create a matrix like a two-dimensional matrix, it fills it by column, by the way. So be careful. It fills from the top down. If you want to change that, you say by row equals true, because you can see, oh, it's no longer available here. Let's start again. You see here, it says by row equals false because we are filling it by columns. In this case, it doesn't matter because we only have one column, right? But if it's a two-dimensional matrix and you want to fill it by row, you want to enter the data by row, you have to say by row equals true. You change false into true. Notice it's case sensitive, so you have to use uppercase TRUE. Also, the dim names, meaning you can create names for the columns, names for the rows, instead of keeping them like, just V1 or whatever. So here again, we are going to fill it with zeros in the beginning, or you can leave it blank, comma, n. That's it. That's all what you want. Now let's go to the simulation. In the simulation, you want to repeat something n times. So you create a for loop. The for loop would loop through it whatever number of times you decide. So you're going to say for I in 1 through n. That's how we create a loop. So you create a counter. In this case, we call it ni. You can call it whatever. You can call it counter. You can call it whatever you want. And this counter goes in 1 through n, inclusive. Once it becomes n plus 1, it will go outside the for loop. Sometimes you want to stop the for loop in the middle. We'll learn about that. You can say break, but that's a topic for another day. You open braces and they close automatically. And the way I prefer to do it, some people do it differently. I keep the first brace with the for loop, and then I click enter, and I would fill the body of the for loop inside. So, and now I don't have to worry about forgetting to close the brace. It's already closed for me. And inside, I will do the following. I will create an x value and a y value. So I'm going to say x equals R uniform. It looks like it's run if. It's not run if, of course. I had a student who say, why are you saying run if? It's R, meaning a random number or a random value or a random deviate, we call it, from the uniform distribution. And when you open the parentheses, it tells you it's going to create a value with a minimum of 0 and a maximum of 1. But that's not what we want. What we want in our case, we want to create it from, I'm sorry, I want to create it from -1 to 1. And I want to create only one value, right? I want to find one x and one y and then see if that combination falls inside the circle or outside the circle. So I'm going to say run if just one, -1, 1. Meaning the minimum is -1, the positive is the maximum is 1. I can repeat this exact same thing and change the x into y. Then I calculate the distance. Notice it's very simple. We wrote what? We created just the matrix, but now we had only two lines in the for loop. The third line is d equals square root of x squared plus y squared. And I'm done. The last thing we do is that we fill the matrix, the pi matrix, with either 0 or 1. So we are going to say pi matrix I, meaning the first run it would be pi matrix 1, the first row, then the second row, then the third row, until I finish 10,000 rows, because I'm running this simulation 10,000 times. I'm going to say this equals either 0 or 1. When would it be 0? When would it be 1? If d is less than 1, enter 1. If d is otherwise or else, enter 0. Correct? Notice that we have that's the long way to say if d is less than 1, pi mat equals 1, otherwise equals 0, or else equals 0, or we learned last time to do if else. I can say if else d is less than 1, comma 1, comma 0, meaning if it's the whole thing. So I wrote it in one single statement. But guess what? I can do it even easier than that. I'm going to say, I don't have to use parentheses. I'm using it for your, it's easier for you. So d is less than 1. That's it. You say, what does that even mean? Notice that d less than 1 is a statement. A statement In logic, meaning something that you can either be true or false. Okay? Like if I say, my name is Mohammed, it's true. My name is Bob, it's false. So, but it's something that you can attribute true or false. True in the computer language means one, false means zero. Notice I didn't say one, it has to be one to be true. No, you can write any number, positive or negative, and it would be true. And if you write zero, it's false. But if I say enter a false value, it will give me zero. Enter a true value, it will give me one. So here, all what I'm saying, this is a shortcut or like a shorthand of saying if d is less than one, enter zero, else enter one, else enter zero. I simply can say d less than one. See how easy it is? And now I'm done. So what do I need after that? After that, I can say pi estimate, my estimate for pi equals, I don't even need to write that, but my pi estimate equals, I can sum all the values and divide them by 10,000. But guess what? This is the same as saying find the mean of pi mat, right? Because the mean is the sum over the count. So I'm going to say mean of pi mat, and I don't enter uh, like an index because I already have all 10,000 stored. So you say mean of pi mat. And then you can print it on the screen, pi estimate. Or you can say cat the pi estimate of the simulation is, and you can format it the way you want. But that's all. Let's run this and see what we get. Oh, I'm sorry. Yeah, I heard the guy reminding me, this is pi over 4, not pi. Did you forget to multiply by pi? I say, oh my God, I'm sorry, guys. Thanks for the reminder. So now I should get a value if the simulation is not garbage, so to speak. Sorry for my French, but if it's garbage, I should get a number that has nothing to do with the actual pi. Let's run it and see. I get 3.1248. What if I run it again? 311 or 312 if I use two decimal places. 317. And you can see that it goes sometimes slightly above, sometimes slightly below. We can change that and make it 50,000. Now I don't need to do anything. I simply run. Now I getting closer, but it's not really like a guarantee. But these numbers are very close to 3.14, which is, pi to two decimal places. And you can see this is 315, 315, both of them. So we are very close to 3.14. Okay, so that's basically how we are going to run simulations. And next time, remember the problem where we had the gap between this assembly that had like a base and two values on the right and the left, and I wanted to find the mean and the variance of the gap. We did that uh, like analytically. Now we are going to run it and see if the simulation would give me something similar. Okay, so again, hope to see you next session and have a great day. Bye. Oops, I'm sorry, I am in the wrong thing.